Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. If you have any questions throughout the session, if you're joining us on Zoom, just look at the top of the bottom of your screen. Wherever your Zoom controls are, you should see a little button that says Q&A. Click on that, hit submit, and I'll get to those at the end of the session. If you're joining me on YouTube right now, just leave a comment in the chat. We are live this week, too. I see Quinn asked if we are live, so I am live. I'm actually not traveling this week, so that's a wonderful thing. So I will be able to answer your questions. So leave them in the chat. And then if you're watching it after the fact, you can leave a comment and we'll get to those as we can. So my name is Jason Gabrinas. I'm one of Snap-on's National Diagnostic Technical Trainers. Been in the training department the last 10 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-on. So I had about 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before that, it was 8 years wrenching at Subaru. So I worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always had the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bag. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is ADAS fundamentals and testing. So we're going to cover a good overview of what ADAS is and kind of how we would walk through some of the resets, relearns, calibrations, that sort of thing. And then we'll also talk about how would I test some of these components, because it could be a wiring problem or something like that you would need to diagnose on a vehicle in order to make one of these things work. So first off, let's go with our overview, our high-level overview. So ADAS stands for, if you don't know, Advanced Driver Assist Systems. And these are the systems they've been putting on cars the last probably a good decade now, at least, of these things getting put on cars. And of course, they become more sophisticated the newer the vehicle is. And we have more sensors the newer the vehicles are too. But some examples such as like adaptive cruise control, electronic stability control, lane departure warning, blind spot monitoring, etc. These are the things that hopefully help us drive the car better and hopefully make the car safer as we're going down the road. It's kind of the overarching theme that we want. So as I said, vehicles can become fairly complex nowadays. So let's just look at the front end of this Mercedes, S-Class, E-Class, what have you. Probably a few-year-old car. But we have stereoscopic camera, multi-purpose camera sensors, can be used for a multitude of things. We'll talk more about that a little bit later. Infrared night vision. We also have camera sensors for the surround view, the parking sensors, right? So we got at least 3 that we can see on the front. Then we have adaptive cruise control, collision, blind spot sensors in there. So there's 3 radars in the front. There's a long range, and then there's a short range radar. I did notice something as I was kind of working through this class. I've noticed, looking around on 22s, 23s, you see out there in the open, in the wild there. I've noticed a lot of differences in the emblems now. It's almost like they're transparent, translucent, kind of almost a smoked out look on some of them. And that is due to there being things behind there, but either radars or cameras, so they're able to see through it better. I've heard stories of, you change the grill with an aftermarket grill, and then all of a sudden your radar cruise control doesn't work. Yeah, it's because the radar right behind that center emblem, and the aftermarket one maybe is too thick that it doesn't allow it to work as well. So these are just other things we have to be aware of as we're going through these systems. Also, ultrasonic parking sensors, and those have probably been around the longest, I think, out of anything. I mean, I remember putting them in after the fact on some Subarus way back in 10, 15 years ago. They were doing that. So they've been around for quite some time, the ultrasonic sensors. Like I said, I think that's kind of one of the earliest sensors. And now we've combined them all to have these really technically advanced cars driving down. There's additional sensors and ECUs under the hood and around as well. So there is a lot of material. And just imagine if this thing gets hit in the front. Even a light hit could be fairly expensive. The 6 main sensors that just about every OEM nowadays uses some sort of combination of these on a vehicle. Some may use all of them. Forward camera, that's pretty much your mainstay now. Pretty much every vehicle is going to have a forward camera for something. Forward radar, both long and short range. A rear camera, that was kind of one of the early things as well between the park assist and the rear cameras. 360 view, bird's eye view, kind of stitches together cameras around the car and gives you that bird's eye view. Side view or monitoring or blind spot monitoring using radar. So you'll have radar on the rear bumpers, maybe even the front bumpers as well for cross traffic alert. And then ultrasonic sensors, of course, like we said, for the park assist in the back. So really it boils down to cameras, radars, and ultrasonic sensors. There's a couple cars using LiDAR, and we'll reference that a little bit towards the end, but mainly it's going to be your cameras and radars that you have to worry about. And then your ultrasonic sensors are also there, but usually there isn't a calibration involved. So speaking of which, let's talk about recalibrating these things. So after a repair, after the car has been in a wreck or something like that, we are going to have to do a reset, relearn, recalibration of some sort on the vehicle. So there's 3 main methods that we're going to use, and you can use a combination of other components and parts, but we have a static recalibration, which is going to be the vehicle stationary in the bay. So usually using some sort of a targeting system in conjunction with a scan tool after the repair. Also a dynamic recalibration. So essentially we're going to connect the scan tool, put it in a learn mode, put the vehicle in a learn mode, and then drive the car after. Sometimes we need to do both. Sometimes we need to do a static in the bay and then drive the car after to make sure that it completes. And then the last one's going to be initialization. So either I just hit a button on the tool and it resets itself, like if you saw in that video at the beginning, or it could be I need to type in maybe a VIN or a code number or something like that in order to initialize it, but I don't need any extra components. I don't need targets. I will need a scan tool more than likely. There's some nowadays that are becoming plug and play too. So that's a good thing looking forward to the future. They just kind of plug it in and it resets itself, relearns itself. So those are fewer and further between, I think. But as we go forward, hopefully, it seems like the manufacturers are kind of getting away from this targets and all. So hopefully we'll get there. Now, why do we need to calibrate these sensors? Well, what happens if a camera's not aligned? What happens if a radar is not aligned on the vehicle? For example, if the pitch angle is incorrect, plus or minus 1 degree, it doesn't seem like much back at the car, but down the road, it is quite a bit. So these systems rely heavily on multiple imaging and sensor processors working together to provide an accurate position of where the vehicle is in relation to its surroundings. The car needs to know where it is in relation to everything else, the lane markers, the other obstacles. Calibration is critical in ensuring the information being processed is precise. Even a 1 degree misalignment of a radar camera or sensor could drastically affect the ability of the system to perform as designed, especially at highway speed. You think going 65, 70 miles an hour, whatever that obstacle is that it can't see, going to be coming up kind of quick. So that's vertical. How about horizontal too, in the plane, going across? At 160 meter distance, a 7 degree field of view is 19.5 meters across. A standard highway lane is 3.65 meters wide. At 160 meters, that represents 1.3 degrees. This is approximately 2.2 millimeters on an adjustment screw or a bent bracket. So if I have, all of these go on that not that great metal quality bracket, most of them. So if the bracket gets a little bit bent, damaged in shipping, I've seen that happen. There are adjustment screws, but like I said, 2.2 millimeters, that's not a lot of adjustment on that screw. That's a couple turns with a screwdriver, and then you're out of whack by a degree, and then the car might not be working as it should going down the road. Here's another example. So this is courtesy of Toyota here. So optical axis adjustment. They talk about optical axis with the camera and beam axis with their radar. So it needs to be parallel or level to the road. So in the example on the left-hand side, this is where my axis was, and I have replaced or removed the windshield or something like that. And then I just put it back. Well, it's going to skew the camera a little bit. And now we see how it's off to the side. versus when we relearn the optical axis in this case, it's going to adjust it to the road that is there and how the vehicle is sitting on the road, right? So the car needs to know where it is in a 3D space. So to do a static recalibration, as we mentioned earlier, what do you need? You need a scan tool for one, and any snap-on scan tool should have you covered on the majority of resets and relearns that need to be done on a vehicle. You may also, in some cases, need recalibration targets and fixtures to hold those targets. Some of those you can get from the manufacturer. Some of you can print right off shop key. There are a couple solutions that we offer as well, our Easy ADAS and our TruePoint, in order to help you out with that too. We'll mention those a little bit later. But here's just an example here on a Honda Accord forward camera. It needs to aim at those 3 different targets there. They need to be the right distance away. They need to be fully lit. And then the car needs to be able to see them. They need to be in the right position. Most commonly, this would be used when we replace a windshield, for example. Dynamic recalibration is a lot easier, or I don't know if I want to say easier, but it's a lot less stuff than I need for it. I really need a scan tool with the right software on it. And then I need to drive the vehicle in what we call a target-rich environment. So it needs other things to see. It needs other cars and obstacles and lane markers and such. So here's an example from a Cadillac. Scan tool is connected to the car. It says vehicle needs to drive faster than 35, avoid extreme accel or decel, follow one or more vehicles. Typical traffic's fine, but vehicles 100 to 165 feet away are most effective at decreasing that calibration time. Drive on a straight road with many stationary objects, and that way it'll be able to recalibrate. This is for a radar in this example. Some cameras do that as well. I've just noticed that. Let's see. So each manufacturer is also different. So things like forward collision warning, they call them different things. Right. So this first column is going to be, what would I generically call this system? And then each manufacturer has its own thing. So lane assist, Ford calls that lane keeping system. Chevy calls it lane keep assist. Nissan calls it lane departure prevention, etc. So every manufacturer is a little bit different. So you have to understand what they call it. And it may be a different procedure even between that. So for example, on this Ford 2016, it's a dynamic for the camera, static for the rear camera, static for the 360. It's just an initialization for the blind spot, and so on and so forth. So you need to know what needs to be done on the vehicle. And that brings me to vehicle preconditioning best practices for ADAS recalibrations. It's important to control the results of the recalibration. Some of these you may not want to get into. Some of them, they're fairly straightforward. It just kind of depends on the vehicle and how complicated it is. So the very first thing you would want to do I need to know, do I need to do a calibration? So you want to review the OEM service information and don't just skim it. Make sure you're not skipping any steps. Each manufacturer is going to have their own requirements. And like I said, even on, could be the same vehicle, could be similar looking systems. As, oh, it uses the same exact radar. Yeah, well, guess what? It needs other stuff. So for example, I need to understand all the requirements. Is it a static? Is it dynamic? Is it both? Is it a reinitialization? What is the process to complete this? Do I need to make certain measurements? Do I need special tools? What systems need to be recalibrated in unison? Sometimes you have to do a camera and a radar at the same time. You want to research your TSBs as well to make sure you check for known problems or if there's a reflash needed for the computer. And then it's also a good idea to review OEM position statements as to what scan tools to use and how to set them up. So those are available at a website called OEM1stop.com. OEM, the number 1 stop.com is a good place to find those position statements. Here's another example. Sometimes you might say, well, it doesn't have this function inside the scan tool. And actually it does. You just might need to do something else. A really good example is 2018 Forester. We actually have a quick tip video on this. And it says if eyesight is selected on the menu of the scan tool, by the way. So if eyesight is selected without pressing the 2 switches at the same time, the camera adjustment items will not even be displayed. So if you do this on the car and you just go into eyesight in this example, it'll just say codes and data. It won't say anything about functional tests. This is something that Subaru put in there for preventing misoperations. So don't mess around with it when you're not supposed to. So what you need to do is you need to press the two lane keep, and then there's another one that my finger's shielding there. But you need to press those two buttons at the same time before you press, and hold it while you press the eyesight button on the scanner. Otherwise, it won't come up. So you won't see anything. Actually, it's a really good example of what you would see in that video I talked about. I referenced it. I think I'll put a link to it in the description after we're done here. But yeah, that's just one example. Another example, 2014 Acura MDX. Depending on what it has, they both have cameras in the windshield, but does the vehicle have forward collision warning and lane departure warning, or does it have lane keep assist? If it has a forward collision warning and lane departure, it needs these two targets, and it's a different process. Or if it has lane keep assist, it needs these three targets and a different process. They're fairly similar, but when you get to certain points, there's going to be differences. So you need to understand what you need to do on that vehicle. You need to make sure that it's specific to that vehicle. Sometimes there's split years where halfway, up until June, they did it this way. And then after June, they did it that way. So you need to know the build date of the vehicle. There's an example that one of our reps was in a shop one day, and they said, hey, I can't complete this reset relearn on this vehicle. No matter how hard I try, it just doesn't work. The tool's just not doing it right. So they said, well, where are you getting your information? And it was from a competitive information source. And we said, well, let's look it up in our information, ShopKey, and let's see. Well, in ShopKey, it lists, okay, so at this date to this date, it's this, and this date to this date, it's that. And they said, well, which procedure did you do? And they didn't have access to the procedure that they actually needed to do on that vehicle. So they read through that procedure, did it the right way, according to what it said in our information, and it worked. So you need to make sure you're checking all this information before you even start. And here's another example too. I just kind of found this out. I hadn't really had much experience with these systems, but it's a F-150, a 2015 F-150, and it's been this way for quite a few years. Inside the taillight, it is integrated the radar. Now, this is a dynamic recalibration, so I don't really need to do anything. I don't need targets or anything like that, but it is integrated to the taillight. So if I replace the taillight assembly, I need to also calibrate this radar. Right? So that's just another thing you may learn just by reading information. After I've read through my information, it's a good idea to do a bulb check, just to kind of understand what systems are available on the vehicle. That would help with that Acura we were looking at earlier. What systems are on, what systems are off. You want to also document the dash condition, what lights are on and off, what's the fuel level, what's the mileage at the beginning and the end, in case you need to do a dynamic recalibration driving it down the road. Good idea would be to quick snap with the your phone, the camera, right, and document it. Vehicle loading. This is also important. Vehicle's curb weight wet, so it needs to be full of fuel, because that's how the manufacturer is planning on it being calibrated. So the vehicle is going to sit differently depending on how much fuel is in it. And the vehicle's fuel level sensor is also connected through the CAN network. So some vehicles won't even let you do a recalibration unless it notices and senses that the fuel is full. Same thing with brake fluid level. Brake fluid level sensor output can cause electronic emergency braking systems to shut down as well. So you might not, that's a two-sided phrase if I ever heard one. So it can cause it not to work if my fluid level is too low and it just won't work at all. And all I got to do is top it up, but it'll be fine. Otherwise, it might not allow us to calibrate if the brake fluid level is too low as well. And we also want to remove any excess weight from the vehicle. So I got a big duffel bag full of free weights in the back. Probably want to remove that. You want to have the correct curb weight and the correct drive height on the vehicle. Make sure the tires are full. Validate wheel alignment. This is also critical. So performing an alignment validation check to assure the center line and the thrust line are equal. You need to understand that when the vehicle's computer is going to make corrections to the direction of the vehicle, like when it has lane assist and things like that, it has to work off an assumption that the thrust angle is not in excess and that the total tow is within the range set by the manufacturer. Otherwise, we could have an issue where it steers too much or it doesn't steer enough. Right? So we need to make sure all of this stuff is in order. It is critical. Like we said, just 1 degree off on that thrust line can be off by 50 feet going down the road. So we need to make sure that it's more than just getting the wheels straight. We need to make sure that that vehicle is aligned properly and within vehicle specs. Just an example, just pull up some of these vehicles. We just looked up a random sample, and depending on what we're doing, they recommend an alignment check, requires an alignment check, or requires a wheel alignment. Recommending alignment check requires thrust line indexing, and so on and so forth. So depending on the manufacturer, they even demand that you have to do that. Then you want a battery charger, battery maintainer, more to be specific. While performing a recalibration, the total current drop from a vehicle can exceed 50 amps because I'm going to have all these different things on. The condition of the battery in the event that it's been sitting for possibly weeks while at the collision shop, you're not sure how that's going to be. Battery jump packs are just to jump a car. They're not really intended to keep it going. Conventional battery chargers also are not intended for computer work. They tend to deliver excessive noise without the voltage and amperage at the correct level. And you really want to look at investing in a specialized battery maintainer like the one that we have, the EEBC 505, which has a reprogramming feature and delivers a clean and consistent voltage and current to the vehicle. Just some cheap $20 thing from wherever down the road is not going to work. Not going to cut it. And then we need to make sure when we're doing a calibration, we need to have a nice clear area. Shop and lighting conditions need to be ideal. Now, I know people do these outside sometimes, and you know what? If I have enough room outside and it's a sunny day, it can't get much more well lit than that. But a lot of shops still have a dedicated bay space for it. So make sure ambient lighting needs to be homogeneous. So, very much the same. I don't want to have hot spots and shade spots, shadow spots. Has to be clear of contrasting areas behind the target. No bright windows behind the targets, and allow adequate space in front of the vehicle and clear the camera's field of view. So example, on a 2019 Honda CR-V, it is 15 feet long. The target placement is 20 feet in front of the center of the right front wheel. The required distance behind the vehicle is approximately 3 feet. So overall distance needed in order to do a calibration on this vehicle is going to be at least 38 feet. Right, so that's a good amount of distance. Some shops don't have that amount of room, so maybe you might have to send it down the road in that case. But just remember, certain vehicles you may need a decent amount of room. Actually, I'm going to show you a little picture here later in the surround view and how much room you might need. In this case, we want to make sure the target is illuminated properly as well. As Toyota says, it needs to be nice and bright. So in this case, they have a light meter on their phone here, and they show the difference in light as to how it's lit up. Right, it needs to be nice and now, for a mechanical setup for a static vehicle recalibration, I need maybe some special tools. In this example, we need this center line thing, and we need some tape, and we need some markers, and we need a string and a plumb bob. A lot of manufacturers, especially a lot of Asian manufacturers, will tell you, here's how to find the center line of the vehicle and line it up off of that. But you need these special tools to do it, or at least, string and a plumb bob and a tape measure. Versus Snap-on has a couple different ways to make that easier. So there's one setup, which was our early version of an ADAS rack, and it was called Easy ADAS. And instead of using strings and things like that, we use lasers. So we can set up the center line of the vehicle with a laser, set up where the center line of the wheel is, etc. And then you will center the rack or the assembly over here, the thing that holds the targets based on that center line, based on that laser. And then the top of the line would be electronic imaging system. So in this case, this is our True Point system. Now it looks an awful lot like an alignment rack or an alignment machine because it uses the same technology as our 3D image aligner. So this allows us, by measuring in 6 different dimensions, distance and yaw and twist and things like that, it allows us to use the vehicle as the reference point instead of the floor. So it's based on the contact patch of the vehicle, and that allows to account for floor flatness and floor levelness. Your floor can be kind of tweaked, doesn't have to be perfectly level, it can be on an angle, because what you do is it maps where the vehicle is in 3D space, and then it uses that as a reference as to where I need to put all my targets. So it's basing it off where the vehicle is, not what the environment is, which makes it a lot easier when it comes to that stuff. So let's talk about the different sensor types and how we would test the components on. So we have radars, we have ultrasonics, we have cameras, and we also have LiDAR out there as well. So radar first. Radar stands for radio detection and ranging. It's been around for a very long time, since like World War II. But it works by transmitting radio waves and then calculating the return time. They're returning faster, they're returning slower. That can help us gauge distance, how long it takes to come back. If it's getting faster, then we know that we're approaching something. If it's getting slower, we're going further away. So front-facing radar sensors are usually used in, say, adaptive cruise control, forward collision warning, and automatic emergency braking. Those are the most frequently ones used, and we can see the differences. So we have short-range radar, mid-range radar, and then long-range radar, which can go up here, way down 200 meters away from the car, versus a camera is going to have a wider field of view as well, but it's not going to be as precise as that. Also, you use radars in the rear of the vehicle as well. So if we have rear side-facing radar sensors, they're usually on the back corners of the bumpers. It's going to help with lane change assist, that little light that comes on in the side view mirror if you're trying to change lanes. Blind spot warning, and also we'll do cross traffic alert as well if there's a car coming down through a parking lot. So if I was going to test a radar on a vehicle, other than firing it and seeing if it fires, which you'd need special equipment for that, but I can use a scope to test it. I can test for power, I can test for ground, I can test for CAN bus. In this case, they have CAN bus in between the two units, and they also go into the vehicle's network as well. So in this case, it's left and right. Left is the master and right is the slave. Or it could be the other way around, depending on the vehicle. But in this case, this is on a Land Rover, and that's how that works. Ultrasonic sensors, like I said, work by transmitting audio waves, super high frequency audio waves, and then calculating the return time again. How long does it take to bounce? Is it fast? Is it slow? So ultrasonic sensors are primarily used for park assist and self-parking systems, as well as object detection and driver notification. So ultrasonic sensors are mounted on the rear bumper and the front bumper, depending on the vehicle. To detect an obstacle up to 2 to 2.5 meters away, the distance is communicated to the driver in real time using varying buzzer sounds. So in these examples, these aren't usually something you would calibrate. You would test it and make sure that the connection's proper. One we may see in a little bit, it's just a CAN bus, so you really can't test anything other than, does it show up on the CAN? But power, ground, they'll have a common power, common ground, and they'll individual signal wires that go back to the computer. Camera turns light into electronic signals, right? So I got my lens right here. It's going to come in, it's going to hit this sensor that's behind it. And then that, using the processing that's on top of it, it's going to turn into an electronic signal that can send out then to the vehicle over the network. Some different types of cameras that we're going to see. Well, the first one's probably the most common, is going to be the rear backup camera. So it can be used for object detection, distance. It can also apply the brakes if necessary as well. Lane centering camera. So a front camera is going to assist the driver in keeping the vehicle centered in a lane. It may autonomously take over the steering when it determines the driver's at risk of deterring from the lane. Uses cameras to monitor lane markings to stay within a safe distance between both sides of the lane. Front-facing pandoscopic camera. So it's going to be a single camera. Going to be used for lane departure, lane keeping, automatic headlight high beam activation. Also used in conjunction with radar to aid the distance measuring as well. Stereoscopic cameras. These are on not that many cars. Subaru has it. It's the most common one. Used for automatic emergency braking, adaptive cruise control, lane departure, lane keeping, automatic headlight dim, and can also, since there's two of them, can also measure distance. And then we also have object recognition view with the camera. So it can tell, okay, there's a vehicle, there's a stop sign. It'll also tell you speed limit signs. If it goes past the speed limit sign, it'll know. There are even some some systems out there now that can detect if you're going the wrong way, which would be very helpful. I know in Connecticut for sure, the last year or so, there's been a lot wrong way accidents on the road. So if that system could work out, that'd be pretty helpful for those types of things. And then we also have surround view cameras as well. Now, I talked about needing room in the shop. Look at this. These two things look like tarps, giant tarps on the side of this Ford. and that is for the surround view camera calibration on the vehicle. So what it does is it takes the wide angle lenses all around the vehicle and stitches them together with the software in order to allow me to see all the way around the vehicle like that. Now, have you ever seen the one with the where it makes the trailer disappear? So that works on the same way. So you mount a camera to the back of the trailer, and then it just uses that information to just kind of paint out the trailer around you. So there's a couple different ways that works. If I was going to test the camera, most of them are going to be shielded video signals. So I might be able to check powers and grounds, and then just check for continuity is going to be about it. Then LiDAR, I don't think has really caught on that much in the consumer market, so to say. Where it's really used a lot is autonomous vehicles. So a lot of the companies that are testing, like Google and whatever, are testing using LiDAR in order to do that. It is found on like a couple different Audis, but it's not very common. This is one off an Audi right there. So this is hooked up to the bus. So it's used for adaptive cruise control, pedestrian detection, emergency braking, that sort of thing. Can use to supplement the radar or replace the radar. So here's that example off that Audi, right? So they call it a distance regulation control module. And then you see we got powers, we got grounds, we got CAN bus on there. So those are the types of things I would test. We can still test it, even though it's a fancy LiDAR system, we can still test it. So let's go live on the tool. Pardon me. Let's go live on the tool and check a few things on here. So I looked up a few vehicles earlier. So we're going to go into that 2018 Forester we talked about. Now, as I said, you need to press the switch to even get in there. Since I don't have a vehicle, I can't even go into any scanner functions on that, even in my simulator. But we can go into guided component test, though, because there are inside guided component tests. If you have a snap-on tool with that function, it's going to have on some vehicles it'll have driver's aid and ADAS. So mirror indicator, detection switch, lane departure warning switch, blind spot monitoring sensor. So that's going to be the radar. Forward collision warning system unit. So that'd be the eyesight system. So the eyesight stereo camera has 2 camera lenses and a control unit built in. Camera recognizes objects in front of the vehicle. And then it sends a signal when it sees something the driver may come in contact with. It'll send a message over the CAN, then a combi meter, and then alert the driver. No action is taken. It can help avoid a collision, apply the brakes. Also serves to operate adaptive cruise control and lane keep assist. Found on the front of the interior and up against the windshield. So there's my pinout. There's what it would look like. Cameras require calibration anytime the cameras are removed, anytime the windshield is replaced, and anytime the vehicle is involved in a collision. So that's just one example. Let's go another vehicle here. F-150. So that's the one with the blind spot monitor on the back. I don't remember if that had ADAS. Yeah, it doesn't. So we can go into the blind spot monitoring module. Aids the driver in determining whether another vehicle is present within a blind spot to either side of the vehicle, expending rearward approximately 20 feet beyond the rear bumper while driving on roads and highways. It goes in a mirror. Also does cross traffic alert, vehicle approaching from 45 feet away up to 40 miles an hour on the left or right side of the vehicle. So it gives us that. Blind spot radar sensors are located on the left and right tail lamp assemblies, like part of the left and right tail lamp assembly. We're replacing either blind spot monitoring module or programming the module. Installation is required. Left and right area, PMI is required. Left and right area of the bumper cover needs to be clear of obstructions for system work correctly. Cross traffic alert cannot be turned off when my key restricted key is in use. And tow bar from the factory automatically turn off when the trailer is connected to the vehicle. So that's good to know. And then it could do a voltage and a ground test. Also in there's going to be, I think we have some scanner stuff we can do on this too. All right, so you can come down here. There's your camera right there. And then I have my side object detection control module. So that's just codes and data on those. I think if I was hooked up to a vehicle, we would have it. Image processing, we do have functional tests though. We can go in and we can align the camera in there, right? So you need that. And it says anytime the rear view mirror has been removed or replaced, the windshield has been removed or replaced. Let's see, program module installation was performed. Procedure requires 2 people to start. Procedure requires the vehicle to be driven for approximately 10 minutes to align the camera. So that is a dynamic calibration. So you'd have to go over 40 miles an hour, avoid lane crossing, excessive steering angle, or sudden changes in vehicle speed. And then it's just going to go through and put it in a learn mode. Takes about 10 seconds. All right, it says vehicle is started in lane departure adjustment mode. And then it says to confirm alignment completion on previously aligned camera, turn the lane departure warning switch and monitor the lanes displayed. While the lines displayed in the instrument cluster while driving. Okay, and then we're complete when we're done. And then it just says check for codes when you're done, and you're done. So another example, GMC Acadia. So this is going to have a little bit of information on both as well. So driver aids, front view camera, object detect sensor, park assist. So the camera could do a voltage test. It's going to tell us where the pinouts are. Top of the windshield. Forward collision alert system detects vehicles in front of the vehicle. And also go into the scanner. Let's see what we have in there. Okay, so active safety control module, camera system front view, for example. Want to do the front view camera functional test. Go into a learn. In this case, if it's already in learn mode, you need to drive it. I think because I popped in here earlier, I must have actually remembered that. So you would go in there, you hit relearn, and then you just drive the vehicle. Yeah. So it remembers that it's in learn mode this time. All right. And then one more is BMW 328i. And going to scanner. And this is a 2016 328i too. So it's got adaptive cruise control, camera-based driver support system, lane change warning. So on lane change warning, we have a functional test in here for initialization. So the sensor system of SWW control unit and the slave must be adjusted in the following case, replacing the control unit or bodywork in the area. So it's going to be located on the right side of the vehicle, left side of the vehicle. We wish to continue. Yes. And then it's going to say adjust which unit. It's going to be adjusted on the next step. Start the procedure. And it's just going to go through a quick initialization. And then if necessary, carry out the slave unit as well. And then it's done. All right. So that's just an initialization as well on that. So a lot of European cars are going to be like that with initialization. I've noticed a lot of Asian vehicles is going to be targets. And then I noticed a lot of domestic vehicles. It's generally a driving it down the road. Inside the BMW, there's a lot of different things inside the ADAS for testing. So, for example, like the camera. Right, so camera is going to have proprietary connectors. Kind of looks like a D-sub connector or like a SS video connector, I guess would be more appropriate. It's got camera. It's got your data. So it's positive and negative data. And then powers and grounds. So we can actually do a signature test on that. And then you're going to see the LIN bus activate back and forth on that. So that's kind of cool that you would be able to check that. They are shielded, so you'd want to use a breakout box to plug in the adapter, but you can test those. They can be tested. All right, so that's your overview testing as well on that. So let's talk about next week. Next week, we're continuing our all new classes as well. So we're taking some of our older classes and updating them, reworking them in this section. That'll be the remainder of the year here. So vehicle network communication overview and diagnostics. So we'll talk CAN bus, we'll talk Ethernet, we'll talk, whoa, hey, back up there. We'll talk CAN bus, we'll talk Ethernet, we'll talk FlexRay, all the different bus types that we're going to be needing to diagnose on a lot of these modern vehicles. So same time and same place as always, every Tuesday, 6 and 9 Eastern. Go to snapon.com/OT if you want to join on Zoom. Otherwise, the 6 p.m. class goes to YouTube, youtube.com/Snap-on Diagnostics. And then 9 p.m. Eastern goes live to Facebook. So it's facebook.com/SnapOnJason. Go give me a follow over there if you use Facebook. And we'll check it out over there. If you want to see any of the other topics in this series, anywhere from, well, we had an intro to ADAS and component testing as well. We get a little bit more in depth on the components in that one. But anywhere from, any of these 72 episodes that we've done, this is episode 73 right now. It's all available for free on our YouTube channel, youtube.com/SnapOnDiagnostics. If you're watching on YouTube, please like and subscribe. Now it's time for questions. Before we get there, let's talk about my buddy Keith, who also does free training. Now his training is live with the tool in front of you. They are not recorded to YouTube, but they're every Wednesday and Thursday. So Wednesday at 7:30 Eastern, 6:30 Central, that is on Zeus. And then Thursday is on Apollo and Triton, a combo class on those. They're about an hour and a half, hour and 40 minutes long. And he goes through scanner functions in the first hour, and then it's scope functions in the second half. So it's definitely a very thorough class. Keith's been with us a very long time. If you want to go sign up there, go to snapon.com/OT and register for his class. All right, let's get to questions. If you joined late on Zoom and you do have a question, just look for that Q&A button, top or bottom of your screen, wherever it is. You can type in your question and I'll look at those. And then on YouTube, once again, use the live chat. So we have a couple folks on YouTube. Quinn, as always, is on YouTube. And he says, am I live this week or traveling? In this case, I happen to be live, which is very wonderful thing because I've been traveling for about a month. So it's nice to stay back in the studio every once in a while. Quinn also says, my train will not do anything as far as ADAS with a Nissan. We have to send them to the dealer. And I think that seems odd. Quinn, if you're still on, and I know there's going to be a little bit of a delay, if you're still on, give me a year, make, model of a vehicle. And that you're having trouble with, and then I want to go into the tool real quick and just see what we have, because I know I've done calibrations on a Nissan before without having to send it to the dealer. So hopefully you're still on, and hopefully you can punch in the chat here real quick. I know there's like a 20-second delay to YouTube, so I'll give it a second. The Winton also says hi. Welcome back as usual, as you are here. I think we're almost there where we need to be. I will just give it a minute. Let me pull up my tool here too. I will start just pulling up a Nissan at random here if I need to. No. Oh, what's a popular Nissan? So let's see. Nissan. That's alphabetical order. So let's pull up like a 19 Murano. It's probably pretty popular, right? Or a Maxima or something. Let's go through here. We'll go down here. So laser radar. Intelligent cruise. Let me go into intelligent cruise. There's a bunch of different variants, so that's one thing. System tests. Auto cancels, functional tests, brake actuators and such, meter buzzers, ADAS buzzers, vibration motors. All right, so let's see more system tests here. All right, so in that case, we're not seeing that one. Let me see this system tests. Go to the default one, not going to be in there. Because I know for a fact I have done, maybe some of them don't necessarily need all that either, but just check. Oh my goodness. There's a lot of different modules. Maybe that's why. Yeah, so I don't see an example from Quinn, so I'm not sure what vehicle. For like radar, front radar maybe. Yeah, so we can do radar calibrations on those. I know I've done a radar calibration on a Murano before because I had one that was broken. It was a rental car. So you can do a radar calibration on that, right? Make sure the vehicle's not moving. Target board. You do need a target, so that's part of it, but you do need the scan tool too. So the functions are in the scan tool. It just depends on the vehicle, right? So that's part of that research, like we talked about earlier. With that, so just understand what the vehicle needs, I guess. All right, with that, thank you very much for spending a little bit of time with me. Hopefully we got a little bit more background on our ADAS overview here. Hopefully you'll join me next week for network diagnostics. So with that, enjoy the rest of your week, enjoy your weekend, have a nice night, and take care.